We're in the device under test right now, an amplifier. We're going to choose the mirrors to be matched together. You see in the HED the optimization matched group. We're going to now pop up to the test bench level, which has instantiated that amplifier. We're going to show down the hierarchy, and we're going to choose the second column, which is the width of the MOSFETs to optimize. It could have been the R and the resistors, the capacitance of the C. And in fact, we're choosing also which analysis statements and corners to use. And we could choose to optimize the width, the length, the overdrive voltage minimum and maximums, and also the V headroom, which is also known as the saturation versus triode. We could force the transistors to operate, for example, in the saturation region by at least, let's say, 75 millivolts. Here we launch the optimizer. The white run, or the first run on the left, is the schematic. And now the optimizer is trying to get a better overall score. You can see the waveform, by the way, which is the typical and the slow run, which is kind of running slow. Green means that you've hit all of the, all corners hit the spec. Red means typical corner failed, and gold means that the typical passed, but one of the outlying corners failed. We're going to now choose this particular run, and we're going to say, hey, take the present values that the optimizer has of the widths and the lengths and the C and whatever, and stay within 10% of those values. So we want to do some fine-tune adjustment for the optimizer. And you see it running, and then what we're going to do is stop it. We're going to choose which run to use as the new schematic, and we will sandbox it, give it a new name of the test bench and the device under test, and instantiate that into a new schematic, and then we're going to run the simulation to see the new happy results. And there it is. You have a nice, faster square waveform.